So we're just going to go through this problem and break it down so that it just becomes super easy. So we've been given 2 points. Here we are. The starting point is 4119.2 latitude, so that's been pretty easy. So 4118, 4119, 4119.2, so it's along this line here, and 7246 longitude, so 72, 44, 45, 46, and remember we're in the western hemisphere, so longitude getting bigger going in this direction. So that's the starting point, and then the ending point is down over here. And so this line here between the two is exactly the track that we would like to take. It's the course over ground. And so the first thing to do is just measure that distance. And so we measure from here to here using dividers, and remembering that this latitude scale here is in nautical miles, so we can just measure this distance from there to there, and it's 15.5 nautical miles. Now the problem is that we want to travel in that direction, but we've got a current that's traveling towards the west, and it's 3 knots. Now we're going to do a 1 hour plot, so current traveling at 3 knots in 1 hour will go 3 nautical miles. And so this line here from here to here is 3 nautical miles, and we'll just kind of prove that by bringing in our dividers, and we'll just rotate that around, and we'll go say from there to there, and that's 3 nautical miles, so 12, 13, 14, 15. So that is the same as this line up here, so we'll just make sure that that is working. And there you go, boom, boom. So that's 3 nautical miles. Now, so that's where we're going to end up if we just sat in that position and waited an hour. We'd end up there. But actual fact, we're going to start driving the boat, and we're going to drive it at 5.5 knots. That's the speed of the boat. And in 1 hour, we will make 5.5 nautical miles. So it's very simple. If we just sat there, right there, we would end up there, but we want to actually drive the boat now, and we want to end up on the course over ground, always, so that we're staying there. So after 1 hour, we want to be on this line somewhere, and if we're traveling at 5.5 knots, we can measure that with our dividers, and that's 5.5 nautical miles, and we just describe an arc right there. And now we know that in 1 hour we are going to end up there. Half an hour would be there, 15 minutes would be there, so we're always going to be along this line here. So in 1 hour we're going to be there. Now what is the real boat speed? Because the current is helping us. Okay, so it's driving us that way. We kind of want to go this direction, so that's actually going to speed us up a little bit. So in 1 hour, if we started there and we ended up here, that would be 5.9 nautical miles, and in 1 hour that makes we're traveling at 5.9 knots. So in 1 hour we would end up there. Now simple math, just go, well, but the distance is 15.5 nautical miles at 5.9 knots. It will take us 2.63 hours, or 2 hours and 38 minutes. Now, the other trick part of the problem is that we have 15 knots of wind. That is a westerly wind coming out of the west. And if we look on our table for our boat at 15 knots, at this angle to the wind, we would have a leeway of 10 degrees. So it will push the boat in this direction. So we want to kind of add a little bit more of our heading so that we can account for getting pushed towards the east. And so it's 10 degrees. So what we do is we just, remember, we would have ended up here if we'd done nothing. So we're going to add 10 degrees to this actual line here. That's the way we want to travel the boat. We just need to add another 10 degrees to come up on the wind a bit, and so we head in this direction. Still going to end up here, because remember, if we head here we'll end up there, if we head here we'll end up there, right? So we're just accounting for this leeway. Now sailboats have more leeway than powerboats, but this problem is for a sailboat. But it could equally work as a powerboat, exactly the same. Probably just wouldn't have as much leeway, so you might end up here, instead of traveling at 183 degrees, you might be at sort of 179 or something at this. But this here shows 173 degrees. If there was no wind, you would go at that direction right there. So there's your problem, and hopefully that sort of pulled it apart really easy for you. And now we'll have some more problems to do on your own. And really go through all the exercises that we give you in this kind of format, because you really need to practice this stuff so that you can be very proficient at it. And it's just called brain muscle memory, right? So you can go through this stuff at any time. You get a chart out, you know the current, you can calculate exactly where you're going, and it just becomes second nature to you.